NASA decided that they want to send CubeSats to the moon, and they decided the best way of doing this was to propose a challenge and let people design a CubeSat.
We are Team Kitcube. We're a group of MIT undergraduate and graduate students working with Project Selene, which is a high school team out in California.
Our concept of operation starts when we initially eject from our launch vehicle and we'll enter a detumbling and actuating phase. We'll then do our initial checkout pointed towards the Earth. After that, we'll start our transit towards the moon. Once we get there, we'll enter our nominal orbit around the moon and we'll complete our operations. So there's several unique things about Kitcube. One thing is our laser comms payload, which we can use to achieve very high data rates. We're also going to be using a new green monopropellant system, which will show that we can have a propulsion capability for CubeSats with a very high delta V.
We're working with what's called a 6U CubeSat, so it's 30 centimeters by 20 centimeters by 10 centimeters. And nobody's demonstrated a real optical communication system on a satellite that's this small. So if we can demonstrate that, and it's not only from Earth orbit, but actually from lunar orbit, that will be a game changer in the ability to send data home from small spacecraft.
The difficult part about using optical communication is that you have to be super precise. So what we're dealing with is using a laser beam and pointing it at the Earth. Within that is a fine steering mirror that we're using to point the laser beam directly at a ground station.
This is a test setup of a fine steering mirror. We start out with a laser beam that's generated out here. We pass it through this fiber optic cable. It comes out of this collimator as a beam, and then it bounces off the fine steering mirror. And then the fine steering mirror has a mirror that tips and tilts in response to commanded voltages. That lets it sweep the beam around, and then we see where the beam falls on the camera's image plane.
We're using a system of green monopropellant thrusters. This is going to be a really great flight test of this fuel, and it's going to pave the way for putting CubeSats into more challenging missions where they have to execute bigger burns and actually form their own trajectories.
It's about the size of a small backpack, and when you look at ours, based on all of our trade space analyses that we've conducted, we have a 6U deployable solar panel. So when you see it deploy, it kind of looks like a beaver tail, which is how we got the name Kitcube for our CubeSat, because a kit is a baby beaver.
But the next step that we really need to move into is buying hardware and making our big picture ideas a reality.
The best thing about this project is really just what it is in concept. We're shooting lasers from the moon to Earth, and it doesn't get much better than that.